So, today we learning vector projection or vector resolution, and let's first recall how we were doing vector resolutions in physics. So if we have, let's say, inclined plane, and we had a mass on the inclined plane, and how we find in the resolution of the gravitational force into the inclined plane, and this angle is theta. So how we will find the resolution of the mg into the inclined plane?
G cos theta times sine theta.
First, how we do? We draw the perpendicular, because only this component of the mg was acting along the inclined plane, and if this theta, then this angle theta. So this obviously will be mg sine theta in this case. So we will find in general, when we have one vector, we have, let's say, x-axis of another vector, we find in the resolution of the vector, we draw perpendicular, and resolution of this vector into this direction is this vector, right? So only this part of this vector is acting in this direction. And then,
Are those two of the same magnitude?
No.
No. Yeah.
well, suppose this is a right angle.
Yeah. Yes.
If this angle is theta, then if this vector, let's say, some force F, what will be this component equal? F cos theta. So that's all we had to do in physics. Now we will do a little bit more in special. The idea is exactly the same. And first we will find the scalar resolute. Scalar resolute. So we have vector A, and we have vector B, and the scalar resolute of A in the direction of B, scalar resolute of A in the direction of B will be, we draw perpendicular, and this length is a scalar resolute of A in the direction of B. If this is angle theta, then this I will put A parallel. That means a resolution of A parallel to B. And because we're talking scalar resolute, it's a length. It's equal vector A times cos theta. Now, what is cos theta from the dot product of vectors, scalar product? We have the cos angle between two vectors equal A dot B divided by length A, length B. Right?
Yeah.
Let's substitute it here. Sorry, length A here, because we're looking the vector, the scalar resolute on the length of this. Substituting cos theta gives us that the scalar resolute of vector A in the direction vector B will be A times A dot B divided by A, length of A, length of B, length of A cancels out, and we get the scalar resolution of vector A in the direction of B will be equal A dot B divided by length B. Make sense? How we got it? It is effectively A cos theta, but we find cos theta from the dot product. Now let's give this vector, we found its length, let's give it direction. What is the direction of this vector? What is the direction of this vector? same as direction of vector b. So we need, if you multiply this just by vector b, if you will do a dot b over b, and if you multiply it just by vector b, will it be correct?
What do you mean correct?
Will it be this vector if you multiply length of this by the vector b?
No.
No. We need multiply not by vector, we need multiply by unit vector in the direction of b, so we will not change this length. How we finding unit vector? So we need multiply not by b, we need multiply by the unit vector. And reminding that unit vector equal vector divided by its length. That's a unit vector. So it's vector in the same direction of b by the length of 1. So substituting it here gives us that a resolution of a in the direction of b will be equal a dot b divided by the length b squared times vector b. This is the resolution of the vector a in the direction of b.
Wait, is the b with the arrow, is that the unit vector?
With the head, it's unit vector.
Wait, isn't it just a times, is this the same as a times b squared? Or no?
A dot b, it's a scalar product. It's a
Yeah.
number.
Yeah.
Divided by square of the length b times vector b.
Ah.
Now, to make it with better understanding, let's consider an example. Open your booklets on the page. Open your booklets.
Politics.
Let's say,
There's no politics.
Today.
Yeah, yeah. So that.
Yeah. Basically like times in the
timing by unit vector to give it direction. To give it direction.
How do you know that?
So, let's open page 31.
Like when we open.
Page 31, example 10. We have two vectors. We have two vectors. Vector A equal 2i minus j plus 3k. And we have vector B equal I plus j minus k. Question asks, find the vector resolute of A perpendicular to B. But to find perpendicular, we first need to find resolution of A parallel to B. Let's apply this formula. Resolution of A parallel to B will be equal. A dot B, what will be A dot B equal? How we finding the dot product? We multiplying 2 times 1 plus minus 1 times 1, so minus 1, plus 3 multiplied by minus 1, so minus 3. This is the scale of how we finding dot product. We multiplying x coefficients plus product of y coefficients plus product of z coefficients. So that will be dot product divided by the length of b squared. So we will have 1 plus 1 plus 1 will be 3. And not putting square root because it's b squared and times vector b. So I plus j minus k. Simple math, 2 minus 4, we get negative 2/3 I plus j minus k. So this is the resolution of vector A in the direction of vector B. Make sense? Does it make sense how I found it? Now, how we find the now perpendicular resolute? Perpendicular resolute will be this vector.
So how do you get 3?
This is what we have in the denominator, square of the length of vector B. Using Pythagoras, we find in the length of vector B because we have x squared plus y squared plus z squared. Now, perpendicular resolute will be this. This will be resolution of A in the direction perpendicular to B. How we can find now? How we can find this vector? How we can find this vector? We know vector A.
Sorry.
And we know vector in the
Isn't that magnitude of b squared?
It is b squared.
This is B squared.
Oh, this is root 1.
1
It's root
squared
3
plus 1 squared plus 1 squared equals 3. If it will be just length of B, it will be square root of 3. So, how we can find vector perpendicular resolute if we know vector itself and resolution parallel? How we can find it?
Pythagoras.
No. We're not looking for length for vector.
Negative alpha parallel plus alpha A.
We have what we get if we add this and this, if we add parallel component plus perpendicular component, they add up to the vector A. This plus this will give us vector A. Will get us vector A. How we can find now A perpendicular?
You didn't make that.
We minus parallel. So we have A perpendicular equals vector A minus its resolution in the direction of B from here. All we need to do now to find A perpendicular, we need to subtract, do A, which is 2I minus j plus 3k minus this vector. Tell me what will be the answer.
8 on 3I
8 on 3I, yes.
minus 1 on 3j
Minus 1 on 3j,
plus
yes.
7 on 3k.
Plus 7 on 3k, yes, well done. So that will be vector resolution, or vector resolute of A in the direction perpendicular to B. Make sense?
But basically, so
Yes.
whatever it says A perpendicular to B, it will always be going upwards.
If A is perpendicular to B, then A parallel will be 0.
No, I mean when it says like find the vector resolute that such that A that is perpendicular to B, like is the perpendicular line.
Can you tell me what the question, which question?
Like example 10, it's the same question. But like
No, but find the vector resolute of A perpendicular to B. That's what it's
so
asking.
then it has to be facing upwards like direction.
It will be perpendicular to B, yes. That's what we do. Vector B, we have vector A, and question asks find the resolute of A, which is perpendicular to B.
Yeah, I know. I'm saying the direction. You're always facing upwards, right? Not going down.
There is no two solutions when we do this. It always will, it not necessarily will be upwards. It can be to the left, to the right, down, can be at the end, but
it's not true. Like if it was going downwards, then you would add
we have direction. Remember,
no
this all those things we find in with the direction.
yeah.
So there is no like two possible solutions or many possible solutions. If you have two vectors, you have this vector, then it always and this vector, there is only one vector that is resolution of this vector parallel to the second vector.
Yeah.
And there will be only one vector which is perpendicular. If you take vector in the opposite direction, like this,
No, I know you can twist
they
it.
will not, this and this will not add up to that vector.
Uh-huh.
If you take this perpendicular down, as you're saying, then this plus this will not make this
No, I'm
vector.
not talking about that. I'm saying if it has the same, like exact same vector, but you flip it like that. Like
It's not same vector.
I know. I'm just talking about if you rub out the arrow, like of the purple thing, like rub it out. And
But
you
then
do
it
that.
will not, but then it will not be
But the
vector.
calculations are the same.
No.
Yes. You find.
If you make arrow this way, this
Then you would have to.
this plus this will not
Yeah,
add up
That's
to this.
exactly what I'm saying. So the perpendicular one is always facing upwards, right? Like connecting.
Not necessarily upwards, it's
No,
always
no.
facing to A.
Yeah, to A.
2A, yes.
When I
Which not necessarily up, it can be down, left,
A
right.
is going like that,
whatever.
it'll be down.
It has to be
Yeah.
to A.
Yes.
Towards A, yes.
Yeah, so it will never point towards B if it was perpendicular to B.
Yes. It always will be pointing away from B. That's right. Okay, makes sense how to work finding the vector resolutes, yes.
Do you need to put like the line under every vector?
This squiggly line, unfortunately, yes. It's annoying and it doesn't make sense instead of put arrow at the top, but that's the notation used in the specialist math course. Okay, like, subscribe and donate to help fight terrorist countries and organizations like Russia, Hamas, Hezbollah, Iran, support Ukraine and Israel.